Algebra 2 Honors, Part 2 of 9.2. I had a phone call and it cut off my video, so I had to start from where I left off. And so in this angle measured in radians, we were talking about going by 45 degrees, and it would take 4 sets to get to pi. It would take 5 sets of 45 to get to 225, 180 plus 45. 270 is 6 sets of 45, which is 3 pi halves, 3 sets of 90. And then we have 7 pi fourths, where you are 45 degrees short of 360, which is 315 degrees. And then 360 is either 0 or 2 pi radians. And then we had done this where I went around with 30 degrees. Do you remember how this works? 30 degrees, and they also hit the 60 degrees. So 30 degrees is where you take pi and divide into 6 equal parts, so pi 6. 60 degrees is 2 sets of 30 or 1 set of 60. 60 is taking 180 and dividing it by 3. It's a pi thirds. And 120 is 2 pi thirds. 150 degrees is 30 degrees short of half a turn. It is 5 sets of 30, so it's the 5 pi 6. 210 is 7 sets of 30, 7 pi 6. 240 is 4 sets of 60, so 4 sets of dividing pi in thirds. 300 is 5 sets of 60. And 330 degrees is your 11 sets of the 30, 11 pi 6. And you will want to know those values just like I did. Okay, so what about when so the pi 6, the pi thirds, the pi fourths, the pi halves are all ones that are just regular ones that you want to just know. But what if they divide it a little differently? Well, right here you see that they're dividing it with a denominator of 9. Well, then what I'm thinking is if I have ninths, that really means I'm taking 360 degrees and dividing that by 9, or not, sorry, I just did 360, 180 degrees, half a turn by 9, and that's going to be 20 degrees. Pi ninths is half a turn, that's why it's the 180, divided by 9 is 20 degrees. So these are going by 20 degrees. So 2 sets of 20 degrees would be the same as 40 degrees. 4 sets would be the same as 80 degrees. 5 sets is going to be your 100 degrees. 7 set is going to be the 140 degrees. 11 sets of 20 is going to be 220 degrees. And 13 sets is going to be 260 degrees. It's 40 degrees plus 220 is going to be your 260. And then 14 pi is 20 degrees beyond the 260. That's your 280 degrees, or 14 times 20, 280. 16 times 20 is going to be 320 degrees. So then you're going to be using radians. And one thing that's helpful to know is that 1 radian is about 57.3 degrees. 180 degrees is pi radians. If you divide 180 by pi, you will get that 57.3 degrees. And 1 radian is where this arc length on a unit circle, so this is a unit circle, and we say unit circle, we're talking about a circle with radius 1. And it's where 1 radian measure is when this arc length is 1. Because on the unit circle, the arc length equals the measure of the angle. So 1 radian is when that arc length on that circle is 1. And so some things are going to be helpful, which we've already talked about. 180 degrees is equal to pi. 360 degrees is equal to 2 pi. So just like you convert from inches to feet to meters, kilograms to pounds, etc., you have conversion charts. we have the same thing that we're going to do when we convert between degrees and 180. This is basically a ratio that we can use. And so if I want to change degrees to radians, I'm going to multiply by pi over 180. If I want to change radians to degrees, I'm going to multiply by 180 over pi. And so at 150 degrees, I want the degrees to be gone, so I want to cancel the degrees, so I'm going to put the degrees in the denominator, and pi radians is, there's pi radians in 180 degrees, so we set it up like this. Again, when I want to convert degrees to radians, I use this, but I just remember I want the degrees to cancel, and so this is how I want to set it up. And then I can reduce the 0. We want exact values, and so that gets a negative 15 pi over 18. And then we can reduce that because they're both divisible by 3, and we get a negative 5 pi 6. And so that's your 150 degrees. I want to see the work on it, not just your final answer. In part B, this is radians. There's no degree on it. I want the pi to be gone, so I'm going to put the degrees in the numerator and the pi in the denominator, although they don't always have a pi in the symbol, so you just need to remember, radians degrees, you multiply by 180 degrees over pi. In this one, it works out nice because the pi's can cancel. I can also take 4 goes into 180 45 times. 45 degrees, right? If you divide 180 in fourths, you're going by 45 degrees. And so you get 9 times 45 degrees. Don't forget your degree symbol, and it is 405 degrees. So you're going to have some of those. You need to show work, and you're just going to be converting back and forth. Now, I've already set you up for some of these degree and radian measures. That pi 6 is 30, pi 4 is 45, pi thirds is 60 degrees, pi halves is 90, 2 pi thirds is 120. All the way around the circle, you want to know these equivalents. You want to be able to go through, take a blank unit circle, and write out all of these pairs quickly with no hesitation. So, I have a little bit of a you try in converting. So I say pause the video, work through these, and then start it up, see how you did. So you should get exact values using the symbol pi on these first 3. And so I want to convert 135 degrees. Well, that's where I'm going to use 180 degrees in the denominator, pi in the numerator, so the degrees cancel. And that happens to reduce to 3 pi over 4. 45 goes into 135 3 times, into 180 4 times. So that is the exact equivalency to 135. For a negative 40, again, it's degrees, so I want to divide by the 180 so the degrees cancel. And so the zeros can cancel. You have a negative 4 pi over 18, but that still keep reducing. It's a negative 2 pi 9ths. Number 11 is a radian measure. So I want to multiply by the reciprocal of what I was multiplying before. I want degrees, so I'm going to put degrees in the numerator, and I want to get rid of the pi. So the pi's cancel. And so I get 5 times 180 degrees. Make sure you have the degree symbol. And then 4 goes into 180 45 times. And so you get 5 sets of 45 degrees, and that's 225, and you have to have the degree or it's wrong. If it doesn't have a degree symbol, it's a radian measure. Now, the 12 is where it can be a little bit tricky. There's no degree on here, so you have to know, well, this is radians. And so I want to change it to degrees, so the degrees need to be in the numerator, which puts a pi in the denominator. But now, since it didn't have a symbol of pi, you can actually just use your calculator on this. There's a pi button on your calculator. Use it for pi. Don't abbreviate it at 3.14. Use the division by pi on your calculator. This will come out to negative 359.817 degrees to 3 decimal places, and that's approximately a negative 360 degrees. And that's because if, 2 sets of 3.14 is 6.28, which is approximately 2 pi. So we've rotated clockwise about a full rotation. All right, so then we have some more bonus with this. Yay. We have some formulas that for area and arc length that use radian measure. It's very important that the angle is measured in radians for these. And so just remember that arc length is this. If I could take a string, put it on that circle, and then measure it, that's your arc length. Versus sector, this is called a sector. This right here, it's like a piece of pizza. You are finding out how many, whatever the units are, how many square units it would take to cover that area. And then this right here is your central angle. So sectors, arc length, central angles, review from geometry. But now we're going to find arc length, and S is used for arc length, is your radius of the circle times the central angle theta. But again, theta must be in radians. And the area is 1/2 the radius squared times the angle, but that angle must be in radians. So you'll have a couple problems on these. And they have some words to read through, but basically you're going to end up just finding arc length and sector area. So a softball field forms a sector with dimensions shown. Find the length of the outfield fence. So here's your outfield fence. And they're trying to show you, since this is 180 and this is 180, I can think of this as a center of the circle, and that's a 90-degree central angle. Well, I want arc length, but for arc length, I want to use r theta, but theta has to be in radians. So the first thing I need to do is change 90 degrees to radians. So multiply by pi over 180 degrees, and that's going to become pi halves. If you don't change it to that, your answers will be wrong. So get the angle, the central angle in radian, and then the radius is 180, and then times pi over 2. And then, so it's exactly 90 pi. So if I say I want an exact answer, it would be 90 pi, and it would be in feet. If they approximated it to the nearest foot, it's about 283 feet. But this is the exact value. So there's the arc length. Then sector area is 1/2 radius squared times theta. So 1/2 180 squared, and then again, the angle, if you're using these formulas, they're different from what you did with degrees, needs to be pi halves, and you need to use show use of these formulas. These are the ones where we're applying radians, and these are the formulas that we use now that we know radians. And so if you work that out and take 180 and square it, divide it by 2, it comes out to 8100, and then the pi halves, divide that by 2 again. So it's 180 squared divided by 4 actually, and then times pi. And then for units, this is area, so it's going to be feet squared. This is your exact answer. It comes out to approximately 25,447 feet squared if you multiply that out. Which makes sense. Pi is about 3.14. 3 times 8 is 24. So yeah, that's in the ballpark there. No pun intended. All right. Okay. Anyway, yeah, here we go. Then using your calculator to evaluate, you need to, there's no degree symbol, so this is in radians. There's no degree symbol, and even though there's not a pi, since there's no degree, this is a radian value. And when I'm thinking -4, I'm thinking, okay, initial side here, 3.14 is half a turn, so I'm probably somewhere around here. And so now to calculate these, again, you need your calculator in radians. And there's still another little trick here that we need to look at. And so with the calculator, I want the sine of 7 pi eighths. Well, right now, mine is in degrees. I need to tap this and get this in terms of radians. And so, and I don't know what just happened with, I don't want that. I just want this. Okay, that's, sorry, Desmos Scientific. There we go. So I need to tap, that's degrees, I need radians. So then I'm just going to go sine, and then I need 7 pi. So now I got to hunt for that pi, but oh, it's right there, right? Second row, third column. 7 pi, and when I hit division, it'll put it in there. And then I'm going to tap to get to the right of the fraction, put my parenthesis. And the sine of 7 pi eighths is 0, go to 3 decimal places. When you get to AP Calc, they have you round, unless otherwise specified, to 3 decimal places. And you have that point 383. But now, for cotangent, why I wanted to get to this is that I don't have a cotangent button. So I'm going to use the fact that cotangent and tangents are reciprocal functions. Excuse me. And so you need to do 1 divided by tangent of -4. And there you have that value, -0.864. Sorry. And that's it.